My name is Flash Isaac, and I'm a teacher from the future. Hello, you are welcome to episode number 74 of the 120 Days to Jamb Physics with Flash Isaac. In this episode, we shall be looking at a summary, questions, and answers under electrostatics and electric field. In the previous episode, or the last two episodes, we discussed Coulomb's law, because Coulomb is a personality, a big name that focused on looking at relationship between point charges. And we discussed that day that according to Coulomb, F, force of attraction, this is gone. You can suppose the ministry is equals K big Q small q over r squared. So the force is proportional to the product of the charges and inversely proportional to their distance apart. If here is d squared in your book, it's the same thing so long we mean the square of distance. And you can do something like this as well. F is equals k q1 q2 over r squared. So these are basically the same thing. And with this, what you should note is that this is charge, this is charge, this is charge, this is charge. Sorry. So this is a charge, this is a charge, this is another charge, this is another charge. So looking for a way to say, okay, this charge is different from this. So that's what we try to do. So okay, this q is one charge, this small q is another charge. Or we say q1 is one charge, q2 is another charge. So just to say they are different charges, not the same charges. Now, if this is true, we said that K is a constant that stands for Coulomb's constant. This is Coulomb's constant. And K is, I think, 9 times 10 to the power of 9. Yeah, that is the value of Coulomb's constant. We did all that, I'm just revising. And this is just my point. So the formula for K is 1 over 4 pi epsilon for just K. So which means, instead of K, if you put this formula for K, force can simply become Q over 4 pi epsilon r squared. Right? Now, this epsilon is permissivity. If they tell you free space, or they say take E naught to be so number, then it means this E is equals E naught. So this permissivity is equals permissivity in vacuum or free space if you are dealing with vacuum. But if you are given a medium or you are given relative permissivity, it means you cannot use E naught to solve. So this formula would work. E arrow is equals E m over E naught. So this is relative permissivity, this is permissivity in medium, this is permissivity in free space. So for a medium, therefore, you'll be given the relative permissivity, and the permissivity in free space is constant. So once you multiply this and this, you get the permissivity in medium. So this is what you now use in this formula for medium. But most times, it is free space you'll be given E naught. In fact, in most of the questions, you just be given the value of K straight. You won't need to do any of these things. So K multiply and you get your answer. Now let's take a look at questions from the Flashlearners Jamb application. By now, you ought to have the application. If you don't have the app, I'm surprised. So visit flashlearners.com or basically your app store or Play Store to install for yourself. Now look at the first question. These are the things we've done before. If there is any question you don't understand or any answer you don't understand, just know that you need to watch the previous two videos again. So aluminium is sometimes used as the leaf of an electroscope because this is simply because it can be converted into thin sheet, and the thin sheet can easily diverge. It is sensitive, it can diverge. Aluminium can be converted into thin sheet and it can diverge easily. That is why it is used or sometimes used as the leaf of an electroscope. We also have gold leaf electroscope, which means you are using gold. Why is earthing important in electrical appliances. Why is earthing important in electrical appliances? Earthing is used to prevent electric shock. If you've ever touched your refrigerator at home, you feel a shock, or you touch a wall, you feel a shock, or you see where there is lightning, immediately there is the thunder strike, you notice someone's TV gets spoiled, appliances get destroyed. All these are earth problems. Earth is a pathway to take fault current, or it's a pathway for fault current to flow, so as to prevent your things from getting damaged. If you have like a long pole or a conductor in your house as that earth, when there is a fault current, so that the fault current goes to the earth and goes down, and such to prevent all this unnecessary shock. Now, once there is earth or proper earthing, it will also help the protective devices to trip. Your fuse at home, once there is your circuit breakers, I don't know whether you know circuit breaker, all those your distribution box at home, once there is a fault, they will trip, they will off, bra. Why? To protect your home from damage or unnecessary current. This is why if your house should be properly wired or connected. If your house is not properly wired or connected, you begin to experience certain things you should not. So, earthing is very important. And this question says, if a charge of 2 microfarad, charge is Q, is equals to microfarad, is situated in a field of intensity. The electric field intensity is 400 Newton per coulomb, which means force over charge. The force on the charge is force is equals motion. So we are given electric field intensity, we are given charge, and we are asked to look for force. Which formula connects force, electric field intensity, and charge? From here, electric field intensity is force per unit charge. So E is force over charge, which means force will be electric field intensity times charge, and that will be electric field intensity is 400 times charge is microfarad. You can take it to be Q if you are not comfortable with this, or anything you like. So charge is charge. 2 microfarad is the same thing as 2 times 10 to the power of minus 6. Micro is times 10 to the power of minus 6. Nano is times 10 to the power of minus 9. Pico times 10 raised to the power of minus 12. So from here, food is ready. 400 is the same thing as 4 times 10 to the power of 2. So times 2 times 10 to the power of minus 6. 4 times 2 is 8 times. In this it says that when two bases are the same and you are multiplying, you simply add the powers. So we pick out of this 10 to the power minus 6 and 10 to the power of 2. We pick one of the bases, we add the power since they are multiplying. So 2 minus plus 6, 2 plus minus 6, that will simply be minus 4. So here is minus 4. Force is in Newton. So that will simply be 8 times 10 to the power of minus 4 Newton. That is the force. And option A is the correct option. Ladies and gentlemen. Let's see the next question here. The instrument used for securing a large number of similar charges by induction is called electrophorus. Yeah. Treated that earlier. The electric field between two charges is shown in the diagram above. What type of charges are at S and Y? If you look at S and you look at Y, you notice something. This is what is happening. The forces, the electric lines of force are going like this, are going like this, are going like this. And I told you that for positive charges, electric lines of force they will generate out. For negative, they will be going like this inside. So the electric lines of force they come out or start from positive and they go in from negative. So when you see forces and the arrows are going out, that is from positive. If you see the lines are going in, that is negative. So for both S and Y, the lines are going out, which means both of them are positive charges, making option C the correct option. The electric field intensity in a place where a charge of 10 raised to the power of minus 10 coulomb experiences a force of 0.4 Newton is electric field intensity. This is also pretty simple. Electric field intensity is force over charge. That is simply 0.4 over 10 to the power of minus 10. This is the same thing as 4 times 10 to the power of 9 Newton per coulomb. Option D is correct there. Calculate the electric field intensity in vacuum. So when you hear vacuum, you know that the permittivity E is equals E naught. At the distance R is equals 20 cm from a charge, so charge Q is equals 6 times 10 to the power of minus 5 coulomb. Calculate the electric field intensity. So they said take 1 over 4 pi epsilon naught to be 9 times 10 to the power of 9 Newton meter squared per coulomb squared. So they are giving you 1 over 4 pi epsilon naught. What is 1 over 4 pi epsilon naught is K. So they are already giving you the value of K to be this. And they're giving you charge and they're giving you the distance of separation. In this case, this formula is not going to work, which is electric field intensity being force over charge. You cannot use this one. This other one will work. So electric field intensity becomes Q over 4 pi epsilon r squared. So Q is 6 times 10 to the power of minus 5 times 4 pi. Pi is 22 over 7 times. In fact, okay, look at this. Times whatever. But to solve this, I think I'm even using the long cut. Epsilon has its own constant. So you can use the value of epsilon and solve. But this is actually a long cut. The shorter cut is simply E is equals force over charge, right? Now, K is 1 over 4 pi epsilon. So this should be K Q over R squared. So this formula will work. This is the same thing as K Q over R squared. And we are given the value of K to be 9 times 10 to the power of 9 times Q 6 times 10 to the power of minus 5 over R squared. But this R is in centimeter. If you look at this unit, they are in meter. So you must convert your distance to meter. So when you convert from 20 centimeter to meter, you are going to get 20 divided by 100. This is 0.2 meter. To convert from centimeter to meter, you divide by 100. So this is 0.2 squared E. This is your answer. When you solve that, I think you should get 1.37 times 10 to the power of 7 Newton per coulomb, as I'm saying in option C. Yeah, that should be the correct option for you. Which of the following is not a method of producing charges? In the previous episode, or the last two episodes, electrostatics, I explained the methods of producing charges, which are by contact, by friction, and by electrostatic induction. So A, B, and D are methods of producing charges, except C. A student is at a height 4 meters above the ground during a thunderstorm. Given that the potential difference between the thunderstorm and the ground is potential difference, that is V, is equals electric potential is 10 to the power of 7 V. The electric field created by the storm is dash. Electric field is electric potential over distance. So the distance is 4 meters. This is very simple then. Electric field will simply be 10 to the power of 7 divided by the distance 4. So 10 to the power of 7 divided by 4. That should give you 2.5 times 10 to the power of 6 Newton per coulomb, as seen in option C. If the work done in moving a 4 coulomb charge Q is equals 4 coulomb between 2 points in an electric field is, so the work done is 300 joules. Calculate the potential difference. The formula relating potential difference and work done and charge is potential or voltage is the work done over charge. Now we have the work done, we have the charge. So the voltage or the potential will be work done 300 divided by charge 4, that is 75 volts. That is the correct option. The force of repulsion between two positive charges 5 microcoulomb and 8 microcoulombs. We have two charges. Let's call the first one Q1. It is 5 microcoulomb, which is 5 times 10 to the power of minus 6 coulomb. The next one is 8 microcoulomb. So the second charge is 8 microcoulomb. That is 8 times 10 to the power of minus 6 coulomb. Separated at the distance. So distance arrow is equals 0.02 meters. They say take 1 over 4 pi epsilon naught to be 9 times 10 to the power 9. And I told you that 1 over 4 pi epsilon naught is the same thing as k. This is another way of saying take k to be 9 times 10 to the power of 9 Newton meter squared per coulomb squared. So this is equals k. We are looking for the force of attraction. From Coulomb's law, the force of attraction or repulsion between 2 point charges is proportional to the square, the product of their charges, and inversely proportional to the square of their distance apart. So, from the data we have so far, we have k to be 9 times 10 to the power of 9 times, we have the first charge 5 microcoulomb, that is 5 times 10 to the power of minus 6 coulomb. So 5 times 10 to the power of minus 6 times, we have the second one 8 microcoulomb, 8 times 10 to the power of minus 6 coulomb. So 8 times 10 to the power of minus 6 coulomb over the distance of separation squared. That is it. And I think you are going to get 9 times 10 to the power of 2 Newton. It is always as simple as that and as easy as that. So 9 times 10 to the power of 2 Newton is the same thing as 900 Newton. Ladies and gentlemen, that is it. And this brings us to the end of this class. I hope you found it interesting. See you in the next class.